Hello, hello. My sound is audible. Hello.
Yes, sir, audible.
Okay. Now we will start our this second sections part. Yesterday we have gone through the title, then central idea, then importance and objective. Now we came to the first point of our syllabus in the second section. So actually I have made certain notes. So first of all, we'll start the definitions of our operation research. Now you can see here, operation research is analytical method of problem solving. So here, this is one method to solve any problems by analytical. Analytical means certain mathematics concept has been used, and once these problems will solve, then upper management will take the decision that is useful for management of organization. Means any problems in industry, we have to get it converts into analytical methods, find out the solution of the same, and after that top managements will take the decisions. In OR, problems are broken down into the basic components. One problem is theirs, we can split into the number of elements, for example A, B, C, D. So one production is there, suppose we are manufacturing bearing. So how many elements are there? Outer casing, balls, then the remaining parts of the bearing. We can get it split, and accordingly we can go for the problem solving. What is the problem to reduce the cost and increase the profit? So then solve in defined steps in by mathematical analysis. So our operation research subject, how we can define operation research is analytical methods of problem solving in industry. After solving that problem, higher level management will take the decisions as per the output got through these analytical methods, and that decisions will go for implementation in such way that industry will get maximum profit with less cost. Cost should be less and profit should be maximum. So this is the definitions of our OR subject. Then yesterday we have gone through this history and developments of the war. The term operation research originated in the World War II when USA and Great Britain sought the assistance of the scientists to solve the complex and very difficult strategical and tactical problems of war. Means in the World War II, some problems it was observed, and how to solve that problem. For this purpose, that they found one technique, that is our operation research technique, and this technique it is used for in that World War. Some examples they have given might be food distribution, cloth distribution, mining, or so many problems they have given so that they will get maximum output. Then next, in 1948, so one club that is formed in the armed force. 1952, the Operation Research Society of USA was formed. 1953, the Institute of Management Science was formed. Yesterday we have seen this. And after this 1953, the concept of the ORs, it has been used in our industry to solve the complex problems in the industry. So this is the history and development. So you have to remember the origin of this war. It is started in 1948 World War II, and it will continuous developments up to 1953, and after that the concept of the wars it has been used in the industry to solve the various problems in the industry. Now, next part, that is methodology. So first point of methodology, define the problem. What is the problem? You can define on the paper. Understand the actually real situation, capture the same and define the problem. What is present situation in the shop floor or in the organization? Try to understand, put on the paper, define in specific manners. This is the first thing in methodology of AI. After that, formulate mathematical models. So here, four types of models are there. So one is the analogicals by using electronic circuit. Then the second is symbolic models. Here we can use our graphs, matrix, what is actually we have observed in our mathematics, maybe equation, graphs, or matrix. This will provide the solutions in the form of cost and weight. So first model, that is the analogical model. Analogical models means it contain electrical electronic circuit. Second theory is symbolic. Here mathematics part is there, matrix, graph, or equation, and this is related to our cost and weight. Second model is this probabilistic model, means probability, uncertainty, means suppose one heat treatment is going on. So we cannot get the exactly hardness in heat treatment. It may get vary. So this is the uncertainty. It is based upon probability. Then next is exactly model, less charges of uncertainties. So here exactly models also we can make, or the probability model also we can make. So this is the point B of methodology of war. Now C point is there. In this C point, develop mathematical solution. Data is applied to the model. Information is computed and results are analyzed to find a mathematical solution for alternative policy. So our C point is develop mathematical solution. Means maybe matrix, maybe equation, or any other mathematical theory we can use to solve these problems and find out the solution of the same. State the different alternative and which is the best alternative. Then D point is there, interpret the solutions, means we have to concentrate what the solution we have got, prepare the information in such form that is meaningful, intangible, quantitative, and translate it into decision. Correct. So whatever the solutions you have prepared, that you have to get in meaningful manners, intangibles, quantitative, means in quantity translate into decision making. And once the decisions are taken, then you have to come to the actual situation, that is the E. Once the implementation or actual situation will occur, then verify the result. Test that statistically. Measure the deviations from the expected result. And if then models can be modified and again cycle is repeated. So this is our methodology of work. Okay. So once again we go define the problem, formulate the mathematical model, develop mathematical solution, interpret the data, find out the alternative, then install the whatever the best alternative, verify that installed activity by the statistical and measure the deviations from the expected result. If possible, you can modify and again cycle is repeated. So this is the methodology of our ORs. So same methodology we can use for research work, while writing papers, while writing funding proposals. Same methodology we can define the problems, come to the models, go to the mathematical solutions, find out the best alternative solutions, then implementation of the solution, verify the result by statistical or any other thing, and if possible, we can modify the same method and repeat once again. This is the methodology of course. Okay, so next in graphical things, I have given this methodology. First of all, actual situation in upper circles, translate into models, develop mathematical solutions. After that, decision making and decision you have to go for actual implementation. So this is the actually graphical things. It indicates the methodology of ORs. It indicates methodology of ORs. Okay. Now application of the ORs where we can use this technique of the ORs. Locating factories, warehouses to minimize the transportation cost. Whenever the transportation is there, in that place we can use this ORs so that reduce the transportation cost. Work allocations to machines for minimizing production time and cost. So many machines are there. How to load all these machines having equal capacity, equal manufacturing things, and in order to decide this, we require the help of wars so that production times and cost will get reduced. For this purpose, we can use war. Inventory problems in industry. Maybe raw material inventory, semi-finished inventory, finished inventory. So inventory, this is the biggest part in the industry. If the inventory is not up to the mark, there may not be continuous production. So in order to achieve that continuous production, we require this inventory. Material handling. So many equipments are there in industry. They may be cranes, maybe conveyors or trucks, fork like this. So utilization of this material handling equipment, it is also depends upon the distance, type of the material to be handled, cost of transportation. So by using these 2 3 points, how we can make use of the war knowledge to solve the problem. Dealings with waiting times. Suppose queue is there, and if queue is there, then unnecessary time will get waste. To avoid this queue, what actually we will have to do? These techniques we will get to the OR. Equipment replacement. Old machine is replaced by new machines. To take that decision, we require the knowledge of the OR. Dividing advertising budgets. Budget and revenue, these are correlated to each other. So depends upon the revenue and the advertising budget, you can distribute accordingly. Then establish the equitably bonus system. Means the bonus, motivation, so many things are in industry. There should be certain policy need to decide from the top management, and for this we require certain logic, mathematical thing in order to take the decision how much bonus will be. So for this purpose we require the OR. So these are the application of the OR. Now next we can use for traffic control also, municipal corporation, PPC, and manpower planning and marketing purpose. Now next, after this application, introduction of linear programming problems. Introduction of linear programming problems. This is called LPP. LPP means linear programming problems. Now in industry, man, material and machines are important resources used by firm means industry to convert raw material into finished product. Main objective to minimize the cost, maximization of profit, but the resources not always available in abundance. There is always restriction of use of resources. If a certain restriction might be there, so management need to divide the limitation resource in order to achieve the objectives. So what is the main uh, the objective of the linear program? So here in this paragraph, it is decided that so maximum profit and minimum cost. In industry, man, material, machines, money are the important resources used by firms and convert raw material into finished product with mechanical or some other thing. The main objective firms to get maximum profit, cost reduction, but resources are not always be available or it should not be in the bulk. There is always restrictions to use of the resources. The resources may be specific quantity or certain limitation over the quantity will be there. In such situation, management to decide the limitation of the resource in order to achieve the main objective of the industry. So, what is the main objective of industry? Maximization of the profit and reduce the cost. And what resources we require? Man, material, and machines. So, with help of these three, we convert raw material into finished product. But while converting, there should be low cost of the manufacturing so that you will get maximum profit. So, in order to achieve this thing, management requires certain logic, and that logic is nothing but our linear programming problems. Linear programming problems. Now, what is actually importance of this or objective of linear programming problem? It comes in this paragraph. Within the two words, it is very simple to maximize the profit, reduce the cost. So this is actually expected in industry. In every industry, the three types of words always be there. Man should be there, material should be there, and manufacturing person. And with help of this, we can convert raw material into finished product. But while making the raw material into finished product, you have to consider there should be maximum profit, low manufacturing cost, then industry will run properly. So for this purpose, we required certain concept, certain analytical methods, and with help of this management will take the decision. This is actually main objective of our linear programming. Now, some terms used in linear programming problem. First, decision variable. It is unknown, need to be determined. Decision variable, it is unknown, means we cannot know, need to be determined. For example, inform produce A, B, C product. Here, decision variables quantity to produce of A, B, C. Means one industry is there and that industry manufacturing of three products A, B, C. But here in this, what is actually decision variable? Decision variables that is unknown. Means how much quantity of A will produce, how much quantity of B will produce, how much quantity of C will produce. So these are the unknowns because we are thinking presently. Correct. So these are the decision variable, quantity to be decided. These are the decision variable. Constraint, limited input. Means a limitation input. Product A quantity X1, product B quantity X2. and x1 plus x2 less than equal to 10,000. So 10,000, this is the limitation. Means product A quantity is x1. X1 is, this is a variable. Then product B is the quantity x2. So x1 plus x2, both quantity if you combine, then it should not be less, it should be equal or less than 10,000. It should be equal or less than. This is the constraint. So in industry, already delivery date, it has been decided. This much quantity we will have to supply on this date. Like this situation is there. Here, same thing is there. Here, two products are there, A and B. A product X1 quantity is there, B product X2 quantity is there. If you combine this X1 and X2, that quantity may be equal to 10,000 or less. So this is one example. Correct. Then objective. What is objective? Maximization of profit and minimization. So every industry, this objective is there. Every problem, this thing will be there. There should be maximum profit and minimization of cost. For example, product A quantity is X1, profit is 4. Per product, profit is 4. Product B quantity is X2, product profit is 5. 5 rupees. Means B product quantity X2, this is the unknown variable. A product quantity is X1, unknown variable. But we will have to give 4 rupees per the per quantity, 5 rupees for per quantity of B type of product. Then objective function can be represented by. So this is the problems you can convert or formulate like this way. Now next thing is their objective functions can be represented by 4x1 plus 5x2 is equal to maximum. Is equal to maximum. So this is the formulation. This is actually linear programming. Okay. So 4 is 1 rupees price, quantity x1, 4 into x1 plus 5 into x1. If we add, then this is the maximum, the what actually expected from the industry, industrial point of view. But in this case, quantity either 0 or greater than 0. It should not be minus. So under this x1 should be greater than 0 or equal to 0, x2 is greater than or equal to 0, non-negative restrictions. So this is the formulations of our linear programming. So we'll take one examples also related to this. So once again, I will go for this. Suppose decision variables, unknown variables, A, B, C, three product and unknown variables for A and B, X1 and X2. So X1 plus X2, there is the limitations of the quantity to be produced. There is a profit. If we sell that product for 4 rupees, there is profit. If we sell that product for 5 for A and B respectively, then objective function should be represented by 4x1 plus 5x2, that is equal to maximum. In this case, your x1 quantity should not be minus, x2 should be greater than 0 or equal to 0. Sometimes 0 production, sometimes greater than 0, but it should not be minus. So up to this, I think you might have cleared the concept of these terms used in linear programming. Formulation of linear programming problem: identifying the unknown variables, that is decision variables as per above. Design the quantity x1, x2, x3, etc. as per above. Express the objective function as per above. Express the constraint constraint should not be greater than equal to this constraint. Express the non-negative constraint and make format of linear program. So at least this is the actually formulation of the linear program. Okay, so I think you might have got the concept of the linear programming. Now we go to the one numerical problem, and after that we'll go to the next thing related to linear programming. Now here a firm manufacturing three products. One firm is there, one industry is there, and that industry is manufacturing three products A, B, C. Profits are rupees 3, rupees 2, rupees 4 respectively. So this is for one item. A, how much profit you will get 3. B, how much profit will get 2. C, how much profit will get 4. The firm has two machines whose processing times in minutes are given. So industry having two machines and industry having two machines. Hello, hello,
Sir.
audible? No,
Yes,
my
sir.
my sound is audible. Hello.
Yes,
Yes,
sir.
sir. Your sound
Yes,
is
sir,
audible.
Okay.
audible.
Okay. Now we came to our numerical problem, which is expected to be asked in your exams or gate exams as well as university exam. How to formulate the problem? So here one industry is there, and that industry manufacturing three products A, B, C. Profits 3, 2, 4 respectively means A, 3, B, 2, C, 4 like this. And that firm having two machines P and Q, and their processing time in minutes are given. Means if you manufacture product A on P machine, time is 4. If you manufacture B product on P machine, time is 3. If you manufacture product C on P machine, time is required 5. Similarly for Q. Now machine P and Q have this 2000 and 2500 available minute respectively. Formulate the linear programming problems. So this is the existing problems in industry. Two machines are there. The processing time is given for each product. Time is available with P and Q, it is given. So within the given times, we have to complete this work. So here constraint is our this minutes which is available with the machine P and Q. Processing time is given, profit is given. Now here what is actually logical things we required from the top management point of view. This is the problem in the industry. We required maximum profit. We require a maximum profit. In order to get the maximum profit, what actually
Sir,
we'll do? Yes, sir. Yes. Hello.
screen is not visible.
Screen is not visible. Okay. 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 नेट गेले ह्याच्यावर दिसतंय का बघा ह्याच्यावर दिसतंय गेलं कुठं आपलं नेट आहे चालू आहे बघ. चालू आहे नाही नाही स्क्रीन स्क्रीन हॅलो स्क्रीन 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 हॅलो हॅलो
Yes, sir.
स्क्रीनिंग विजिबल ना
Visible.
yes
Yes,
yes
visible.
okay now here internet problems in our college I have started my own internet it is visible to you what actually I written visible or not hello what I have written it is visible no
Yes,
hello
yes.
okay so already we have gone to the terms used in linear programming problem decision variables means unknown quantity to be produced then constraint how much quantity will going to produce by the unit A and B and addition of this it should not be uh, less than equal to certain amount we say then objective functions in order to get the profit the quantity of x1 plus quantity of x2 that should be the maximum and formulation of the problem here I have given identify the unknowns or decision resources. After that, we assign the quantity, express the objective function, express the constraint and non-negative variable. So up to this, we have gone through this. Now, this is actually problem. It is asked in your exam, maybe GATE exam, how to formulate the problems by using linear programming. So here one industry is there. Once again, I will repeat one industry is there, three products in that industry ABC. Then profit is given 4324. Then firm has two machines whose processing time is given. Okay. So here machine P and Q available time is given 2000 and 2500. Formulate the linear programming problem. Okay. So here three products are there means quantity produced by machine of ABC that is the unknowns. So decision variables are X1, X2, X3. X1 means number of product A to be produced. X2 means number of product B to be produced. X3 is number of product C to be produced. So X1, X2, X3, these are the decision variable. Unknown variable is how much quantity of A will produce within the available times. How much the quantity B will produce within the available time. How much the quantity C will produce within the available time. Available times it is given above. So available times means actually delivery date of that product. So once we get the orders, we have to decide the delivery date. So management will take the decision within the specified time, maybe 2 months time, working time, and within this we will produce this much quantity. If we produce this much quantity, this much profit will get, this much cost will get reduced. So this decision we actually required through this mathematical uh, formulation. So here three variables, three products, three variables are there, and here time available. These are actually constraints. 2000, Now next thing is there where x1, x3 are decision variables. Objective function. What is the objective of this? Objective maximum profit from the product. Three product, there should be profit maximization. So in order to maximize profit, that P that is equal to 3 into X means X1 is the quantity produced by A. And what is the profit? 3. So 3 into quantity X1 plus 2 into quantity, this is related to B. 4 into quantity, this is related to C. So P, this is equal to 3x plus 2x2 plus 4x3. So this is your objective function. This is your objective function. So whenever problem is there, first you have to formulate this problem. First you have to decide the decision variable, then come to the objective function, and then you come to the constraint. Now we have formulated this. How we can formulate it? Unknown quantity, or that is called the decision variable X1, X2, X3 manufactured by our this A, B, C on the both machine. And addition of this is equal to maximum profit. So this is actually objective of the our management. So this is the mathematical equations to uh, solve the problems in the industry. Now next constraint at P total minutes. How much minutes are available? So 4x1. So x1 quantity per quantity is 4. For x1 quantity, 4 into x1 related to A product plus 3. This is the processing time. So if you see the chart, this 4, 3, 5, this is the processing related to A type of machine. So 4x1 plus 3x2 plus 5x3 means this is actually total minutes, and this at Q, this is 2x1 plus 2x2 plus 4x3. So this is the time available. Now maximum capacity of P as per our first equation, it should be equal or less than 2000, and maximum capacity of Q, it should be less than equal to 2500, where x1, x2, x3, so these are the minimum. Okay, so this is the formulation of the problems in the industry. This is actually formulation of the problem in the industry. Once again you can see this. See this. This is the problem in the industry. Once again we'll read and we'll go through this. uh, one industry is there, and that industry they are manufacturing three products, and the profit for each that is given 3 to 4 respectively. And as per the manufacturing firms whose processing time is given, P machines, Q machines, A product is there, 4 minutes is required to process product on P machine. B product is there, 3 minutes is required to process that product on P. C product is there, 5 minutes is required per product. 5 minutes is required to process on P. Similarly, if you process product A on Q, then 2 minutes is required. If you process product B on Q, again 2 minutes are required. If you process product C on Q machine, 4 minutes are required. So here maximum times available with P and Q, it is given. Now you have to formulate this problem. So only formulation is there. Result we have not discussing. After this result and how to solve this problem will be there. So our point, how to formulate the linear programming problem. This is our first point. How to formulate linear programming problem. So this is the situation in the industry. Now you have to formulate the problems in order to achieve the objective. What is the objective? Maximization of profit and reduce the cost. This is actually main objective of our management. Now here those are not known to us, that is our decision variable. Because here how much quantity to be produced in order to achieve the target date, that is the decision variable. Unknown variables, we don't know variable, but we presently we have to decide that variable. X1 how much quantity will produce, X2 how much quantity will produce, X3 how much quantity will, that initially we have to decide. So this is the decision variable, unknown variable. And after this, here we have gone to the formulation of objective of this uh, problem. So here's maximization of profit. Maximization of profit. Here you have to consider only profit. So here 3 to 4. 3 for A product, 2 for B product, 4 for 4 that is for product C. So x1 into 3, this is related to A. 2 into x2, this is related to B. Then 4 into x3, this is related to C. Addition of all these, that is equal to maximum profit. This thing actually management is expecting. This thing actually management is expecting. Then constraint. But what is the constraint over this? Related to time. Time is the constraint here. So at point total, as per the time, the total for A product, if we select machine P, for A product, how much time is given? 4. So 4 into x1. For B product, how much time is given? 3. 3 into x2. For C product, how much time is given? 5. 5 into x3. And this total time, it should be less than equal to 2000. This is related to our P type of machine. Similarly, Q types of machine. Similarly, Q types of machine, maximum quantity at Q, that is the 2x1 plus 2x2 plus 4x3. This is equal to less than equal to 2500, where x1, x2, x3, these variables are not negative. It may be 0 or it may be greater than 0. Now here linear programming models can be written as here. Now how we can write the linear programming for maximize P. P is the profit. So 3x1 plus 2x2 plus 4x3. In order to get this profit subjected to constraint. So whatever equation related to time we have formed, this is actually constraint. So here, which constraint is there? 4x1 plus 3x3 x2 plus 5x3 less than equal to 2000. Similarly, 2x1 plus 2x2 plus 4x3, this is less than equal to 2500. This is the constraint. This x1 x2 should be greater than 0 or equal to 0. So this is the for technique for formulation of the linear programming problem. And whatever equation it is with how many equations are there? Three. One is related to profit and remaining two, this is related to time. So these three equations we have to solve, and after solving how much quantity it is expected to be produced by P machine related to A, related to B, related to C. How much quantity to be produced by Q related to A, B, C. And this thing you can put on the papers and give to the worker. So this is my solution. Now, if you do this thing, then I will get profit. Otherwise, the company will come in loss. So this is the actually things it is expected in the industry. First, you have to decide the profit maximization equation, and after that, you have to decide the constraint. And in that constraint, whatever variables are there, it should not be equal to 0 or greater than 0. Some basic steps here I have given. Procedure of simplex linear programming problems. First step, formulate the problem as per this linear programming. Converts inequality into equalities by introducing slack or surplus variables or artificial variables. So while solving this above problem, we can do some surplus variable or artificial variable. Because of that, there is no effect on the actually production or quantity. So this actual thing it is required in mathematics. So this is the uh, first thing which is required in simplex means convert inequality into equality. If inequalities problems are there, you have to convert into equality by addition of slack variables, surplus variable, artificial variable, two, three variables you can use this. Then initial situation here, m is the number of constant and n is the number of variable. Number of constant and number of variable. Variables above equation we have seen three variables are there. M is number of constant. How many constants are there? Two. Your time is the constant. Two is the our this. Then n minus m means 3 minus 2 to getting the solution should be set to 0. So n minus m to set the starting solution should be set to 0. Means here our n is the number of variables, that is 3. M is number of constant, that is 2. So n minus m to getting the starting solution should be set to 0. So whatever difference you will get, that is 1. But it is expected to get the optimum solution, it should be 0, and prepare the initial simplex table. Okay. So whatever this 1, 2, 3, 4 points are there. So just you have to remember only this. Tomorrow we're going to start one numerical problems related to this, related to the formulation of the problem as per the above industrial problem. So this is about the or problem formulations. So just we'll go for revisions and then we'll stop here. Today what we have covered, today we have covered definition of the wars. What is the definition? Analytical methods to solve the problem. It is useful for decision making at top management. History developments. World War II. This subject has been originated and actually in industry it has come in 1953. Then the methodology, define the problems, formulate the problems. Certain models are you have to use and develop, interpret, implementation, installs, and verify that. And after this, in graphical way, I have shown here three circles are there: present situations, then yours uh, translate into the mathematical models, then develop mathematical solution, decision making, and go for implementation. And after that, you have to verify. And if the result is a little bit vary, you have to go for modification, repeat that cycle. Application, industry, military organization, manpower problems, inventory, transportation, waiting theory, equipment replacement, bonus system, anywhere we can use this our wars. After this, here production planning, municipal corporation, and hospitals. So whenever the situation in the hospitals or municipal corporation is worst nowadays, to solve these problems nowadays, problem of hospitals, we can make use of this war technique. Q might be there, where we can give the first preference. So logical answer should be there. Then introduction of linear program, man, material, and machines convert into finished product. But while this producing this product, there should be less manufacturing of maximization of profit. Then here terms used in our linear program: decision variable, constraint, and objective. Objective: maximize profit, reduce the cost. Constraint: maybe time. Time is always the constraint. Maybe the profit constraint sometimes they will give. Then decision variable, the quantity, and you convert this thing into uh, problems, mathematical relation. So here I have given one example. Uh, Industry profit and processing times is there related to three products and processing on two machines. In order to get maximum profit, what should be the relation? So here at last, in the last PPT, I have given this solution. So this is the formulation of the problem. See here, maximize P. P means profit is equal to 3x1 plus 2x2 plus 4x2. This is the first equation subjected to constraint. So what is the constraint here? Time constraint is there. Or equation 1 less than equal to 2000, equation 2 less than equal to 2005. Now 1, 2, 3, three formulas, three equations are there. These three equations we have to solve, correct? And after solving, for maximization of profit, what should be the x1, what should be the x2, what should be the x3? This is actually expected in this linear programming. Okay, so with this, I think our time is over, so we will stop here. And next lecture will take the problems related to this linear programming. So today we'll stop here.